Hello world, welcome back to another picoCTF 2022 write-up video. In this video, we'll be solving the forensics challenge SideChannel worth 400 points. Let's get into it. There's something fishy about this pin code checker. Can you figure out the pin and get the flag? Download the pin checker program here, pin_checker. Once you've figured out the pin and gotten the checker program to accept it, connect to the master server using that and provide it with the pin to get your flag. Okay, so the title of the challenge kind of gives away what this is supposed to be. It's going to be a side channel attack, and I don't find this is more of a binary exploitation challenge than or even a reverse engineering challenge than I would think a forensics challenge, but whatever the case may be, it's not that bad. So basically with side channel attacks, the idea is if you get part of the pin right, like a character or something, or even a password or something like that in the program, in theory it takes longer or more instructions, right, to realize that that part of the pin is correct, as opposed to if the pin was entirely incorrect or one of the characters is not correct. Then it would be shorter, like a least amount of instructions to say, hey, this is incorrect. So basically, we don't need to measure the instruction count per se. We just need to measure the time it takes to execute the pin checker with a pin. And we just loop through each digit of the pin until, like, basically, here, I'll just show you. So I've already written a script for this, and I was gonna write it through like I usually do with these challenges, but we're running out of time, so I kind of had to speed things up. So I already have it here, and I will explain how it works for you so you can understand kind of the thought process here. Okay. Oh, well, first maybe I should demonstrate how to actually run the pin checker. Okay, so all you got to do is, of course, let's run a file on it. Yep. So .pin_checker. So it's looking for an 8-digit pin. Perfect. We only have to deal with the numbers 0 through 9. So this is going to be much faster than anything else that we would do. Incorrect length, whatever, okay? So over here's my little exploit script. Okay, I'm using subprocess in the time libraries. And we start off with 99999. You want to start off in that character range that it's going to be in when you're brute forcing the code. Because if you don't, you're gonna get random values. Like originally I was starting this off with like a bunch of A's or whatever, and then I was just replacing each A with a digit, and I was getting different keys each time. So once I finally got a proper pin, I only got a proper pin once I actually converted my starting seed, kind of, with purely digits. So here's my starting seed, of course, for the pin, and then we're gonna loop, like, we got 2 loops. The outer loop is gonna take care of, okay, go to each position in the pin. And then it's gonna take each position in the pin, and we're gonna do this next loop, and it's gonna loop it from 0 to 9. And it's gonna set the pin index from the outer for loop to whatever the inner loop's value is at that time. And then we're gonna open a process right here for the pin checker. And then we're gonna start the timer, of course. And then we're gonna p.communicate, which is just me sending the pin checker our modified pin, right? Our indexed pin. And then we're going to append to the times list up here, and I did nanoseconds to make it more granular. I think normal time would have worked too, but I just wanted to be as granular as possible because I didn't know how detailed this challenge was going to be. And we're going to subtract the start time from it, like our current time. And the reason why I do that is because in the next one, right, we're going to say, hey, the actual index of the pin, right, whatever index we're on, this will be permanent, right? Because this is outside of the inner loop. So this is going to set whatever that position is at I, it's going to be permanent for this, at least for this run through. So we're going to set it to times.index, and then we're going to get the max value of the times array. So whatever the maximum amount of time it took for that digit or that pin code, we in theory know or think that that's going to be the actual digit at that position for the pin. I hope that made sense, because at the end here, all we're doing is resetting the times array, right? Because we're gonna refill it with new times and get the max again. And then we're going to just, at the end, print the entire pin and join it together. Now, I kept this inside the inner loop because so we could just see the process as it goes, so that it would make more sense to you in case my explanation was a little wonky. So we're gonna go ahead and run the exploit, and you'll see that, hey, we're trying, it went through and it found 4 first as the, first digit, and then 8, and then 3, and then it's just gonna keep going, right? I think the next digit's a 9, and then a 0, then a 5, almost there, then a 1, and then finally a 3. Okay, so now if we run the pin checker and we enter in this, access granted. Notice if you put in an improper pin, see how quickly it denied it? That just shows you that this is susceptible to a timing attack, which would be the side channel attack, because you saw how quickly it reacted to our correct pin, right? It was pretty slow, but it reacted pretty much immediately to our incorrect pin. So there you go. Oh, well, I guess the pin out on the server and see if we got it right. It should be the same pin, so paste that in. Grab that. Please enter the master pin code. picoCTF timing attack. And there you have it. If you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.